as the name suggests, the name of the chapter is matter. So, in this, what we need to learn about matter? Now, matter is anything which we see around us. That means chair, table, books, water bottles, everything, even we ourselves, we are all examples of matter. The sun, the moon, the stars, everything, it is an example of matter. Now, according to science, what is matter? Matter is defined as anything which occupies space and has mass. That means anything which has got some mass. That means if we just lift it, we will find that it is heavy. And if it occupies some space, that means when we are keeping it at a particular place, it will occupy some space. That is called matter. Now we are coming to characteristics of matter. Matter occupies space. That means what? When we are talking about matter, let's take an example. The physics book itself. When we are keeping it on the table or on any other place, it is occupying some space. As you can see, it is rectangular in shape and it is taking up some space. So, matter is occupying some space. In other cases, if we have a look at any other object, a chair, a table or a bicycle, everything, a motorbike, everything, all these take up some space. And this, we can say, this space which is occupied by matter is called its volume. So, matter occupies some space and the space occupied by the matter is called its volume. In experiment number 2, it has been shown that matter occupies space. What has been done? A glass tumbler full of water has been taken and it is placed on a beaker. Now, what we see? We just immerse a stone over here, immersed in the tumbler containing water, some water is overflowing. This proves that matter occupies space. Matter has mass. What is mass? The quantity of matter contained in an object is called its mass. Now, it can be proved by activity 3. What we have to do? We have to take a spring balance and we have to tie an empty can by means of a thread to the hook of that spring balance. We will find how heavy it is. How? By the reading of the spring balance. Then we shall fill up that can with water. Then after filling up the can with water, we will find it becomes more weighty. How? Because the readings of the spring balance once again change and it shows us that it becomes more weighty or it becomes heavier, or in other words, its mass increases. So we can prove that matter contains mass or matter has mass. Next we come to composition of matter. Now composition of matter, what it is? Matter is, remember, made up of atoms as well as molecules. That is, these are the particles making matter. Now what are atoms? Matter is made up of very tiny particles called atoms. Usually an atom does not have an independent existence. That means what? The very small tiny particles making up matter are called atoms, but atoms do not exist independently. Next we come to molecule. What is molecule? It is the smallest particle of matter which can exist independently and retain all the physical and chemical properties of matter. That means molecule is the smallest particle of matter which can exist itself and it can also retain or it can have the characteristics of the matter. So, atoms do not have a proper independent existence. That means if we keep some atoms together, they'll immediately join up together to form a molecule. And molecule is that smallest particle which can exist independently, having the characteristics, that is the physical and chemical properties of matter. Now matter can exist in 3 states: solid, liquid and gas. Solids, you can take the example as a book or ice, like this. Liquid, example water. Gas, you can take the example of oxygen gas or water vapor. All these are examples of gases. Now we are coming to arrangement of molecules. Now whenever we are learning this, we need to keep in mind 2 important terms: intermolecular force of attraction and intermolecular space. intermolecular force of attraction. What it is? The molecules of a substance are held together by a force of attraction between them, and that force of attraction is called intermolecular force. Next we come to intermolecular space. The spaces between the molecules for different states of matter vary. And what is this intermolecular space? The space between the molecules of a substance, or the space between each and every molecule of a substance is called the intermolecular space. In solids, the intermolecular force is strongest and intermolecular space is almost absent. It is very, very less. So, molecules are very closely packed and they can hardly move about. The molecules can only vibrate. Next we come to arrangement of molecules in liquids. In liquids, intermolecular force of attraction is not so strong as in solids. The intermolecular space is more than solids. That is, molecules are less closely packed and molecules can move from one position to another in a liquid. Remember, this is very important. The molecules can move from one place to another within a liquid, but they cannot leave the liquid surface. Next we come to arrangement of molecules in gases. In gases, intermolecular force of attraction is weakest. The intermolecular space is largest compared to liquids and solids. Molecules are free to move in whole available space. That means the molecules of a gas can fill the whole available space of the container. We come to the properties of solids. Solids have a definite shape. This is point number 1. Why? Because solids are having a definite shape, as the molecules of solids are very tightly packed, so they cannot move about freely. Number 2, solids have a definite volume, as solids occupy some space. Next, number 3, solids have a texture. So when we are touching the solids, you will find that solids might be hard, it might be smooth, as well as soft and rough. Solids have many free surfaces. Why? Due to strong forces of attraction between the molecules of solids, solids are compact, so solids have many free surfaces. That means we can touch the solids on different surfaces. Solids are incompressible. Solids cannot be compressed. Why? As in solids the molecules are very closely packed, so they are strong and compact. And also they expand or contract to a very small amount on being heated or cooled. Next we come to properties of liquids. Point number 1, liquids do not have definite shape but have a definite volume. That means liquids do not have a definite shape. They take the shape of the container in which they are poured. Whenever a liquid is poured in a different container, it takes the shape of the container. We have also seen it in our lives. So when you pour some water in a bottle, it takes the shape of the bottle. When you pour it in a glass, it takes the shape of the glass. Why this happens? As the molecules of liquid are very loosely packed and they can freely move about. Liquids have a tendency to flow. This is point number 2. Now, this tendency of the liquids to flow is called fluidity. And as the molecules of liquid are not sticking to each other, they are sliding, or they are able to slip or glide over one another. Due to weak intermolecular force of attraction, liquids can easily flow. Liquids cannot be compressed as much as spaces between the molecules are more than solids. Liquids can be compressed by a small extent. Liquids have a free surface. Liquids have only one free surface at the top. Next, properties of gases. Number 1, gases have neither a definite shape nor a definite volume. That means gases do not have a definite shape as well as a definite volume. Why? Because in gases, intermolecular space is maximum and there is negligible intermolecular force of attraction. That means the intermolecular space is very, very large in case of gases. Why? Because hardly the molecules attract each other, or the intermolecular force is negligible. Number 2, gases have maximum fluidity or capacity to flow. Gases can flow from one place to another. This thing we all know. If we just take some perfume and just we spread some perfume in one corner of the room, immediately we will find the smell of the perfume from the other corner also. Why? Because the gases have the maximum capacity to flow. And why this happens? As molecules of gases move about freely, they can easily flow. Next, number 3, gases are highly compressible. That means gases can be compressed. A container containing a gas can be easily compressed, as there is a lot of empty spaces between the molecules of a gas. That is why balloons containing gases can be compressed also considerably. Number 4, gases have no free surface, as molecules in gases move very quickly in all directions, so it has got no free surfaces. Next, we come directly to fluids. What are fluids? Those substances which can flow, they are called fluids. Now we know that solids are not able to flow, but liquids and gases, they can flow, so they are called fluids. Next, we come to comparison of the properties of solids, liquids and gases. Number 1, shape. First property is shape. So solids have a definite shape, liquids have no definite shape. They take the shape of the container in which the liquid is stored, and gases have no definite shape also. They also take the shape of the container in which they are kept. Next, number 2 point, volume. Gases have no definite volume, liquid have a definite volume, and solids also have a definite volume. Next, compressibility. Solids are not compressible, liquids can be compressed slightly, and gases can be compressed highly. Next, we come to fluidity. Now, what is fluidity? I had already said it is the capability or capacity of a substance to flow. Now, can solids flow? No, so they are rigid and they can't flow. Liquids can flow and gases can flow very easily and very fast in all directions. Next, we are coming to point number 5, that is free surface. Solids have many free surfaces, liquids have only one free surface, and gases have no free surface. Point number 6, space between molecules. Solids have almost no space or negligible space between its molecules. Liquids have some space in between the molecules, and gases have lots of space in between the molecules. Next, point number 7, attraction between molecules. In case of solids, the attraction between the molecules is very, very strong. In case of liquids, the attraction between molecules is not so strong, and in case of gases, the attraction between the molecules is very weak. That is, the force of attraction in case of gases between its molecules is almost negligible. Point number 8, movement of molecules. In case of solids, we know the molecules can't move, they can only vibrate at their fixed positions. In case of liquids, molecules move around within the liquid. That means the molecules can move, but they are not free to leave the liquid surface. They can move only within the liquid. And in case of gases, the molecules can flow easily in all directions. Thank you.